On the right side, you can see our test device. It features an RGB LED that can be seen as 3 individual LEDs with the colors red, green and blue. The cable you see is only for the power supply. Let's look at the mesh elements of this test device. Mesh element 0 is the red channel. Element 1 is green and element 2 is blue. There's also element 3 which controls all of the LEDs together, but we will explore that one later. Element 0, the first one, also has a configuration server. This is a mandatory model required for all mesh nodes. These aren't critical right now, but you might need them later when adjusting network parameters. Let me show how that looks inside the nRF Mesh app. The configuration server allows us to set up mesh networking features of each node, such as relay configuration, network transmit settings, and enabling or disabling features like the friend features, heartbeat publication, and heartbeat subscription. On top of that, we have a generic on-off server. A server holds a state, in this case the state for the red LED channel. It can be on or off. To make things clearer, I'll label the first element red, the second green, and the third blue. These are local identifiers only, just to help us keep track. Let's try to turn on the red LED. We go to the red element and use its generic on-off server. First, each model must be bound to an app key. We only have one, so we'll bind it. We'll skip publication and subscription for now. Also, we ignore the settings for transition time and delay. For now, we are only interested in sending on or off messages to the node. Let's read the state of the red LED channel. It should be off. It is. Now we turn it on, off, on. It works as expected. If you pull down to refresh, the configuration is reloaded from the device. Now let's set up the other channels, starting with green. Bind the app key, read the state, it is off, turn it on, off, works perfectly. Now the blue channel. Bind the app key, read the state, it is off, turn it on and off, all working well. Now we can mix them. Let's turn on blue and red. This should give us a pinkish color. Great. Now turn them both off. It's important to note that reading the state doesn't happen automatically. For example, if the LED is on and you leave the screen and come back, the state will show as unknown. You'll need to manually refresh the state. Now we have a setup where the phone, the provisioner, can send messages to the individual elements using generic on-off servers to control the LEDs. The app is sending these messages to the nodes through the initial connection created during provisioning, which is fine for now. Let me show you the last element, which includes a vendor model. Vendor models are non-standard. Generic on-off messages we've seen so far are interoperable across different vendors. A vendor model, on the other hand, is specific to a device manufacturer. It allows sending and receiving raw byte data. For this test device, the last element controls all LED channels through a vendor model. It supports a very simple protocol where the state of each of the 3 LED channels is encoded into a 3-byte message. Each byte represents one LED color and can be either on or off. Here we have the vendor model controls. We need to specify an opcode and parameters. A device may support different opcodes with associated parameters. In our case, the device supports just one opcode, which is 0. Don't worry about the prefix C0. It's added automatically by nRF mesh. The first byte is the state of the red LED. 0 turns it off, 1 turns it on. Let's turn it on. Turn off red and turn on green instead. Turn off green and turn on blue instead. Turn on blue and red together. Finally, turn on all channels together. And this is how vendor models are working. You need an opcode plus parameters encoded as byte array. The next video will show how to configure multiple nodes to communicate with each other.